All right, it's time to find limits numerically. The majority of our work so far has been finding limits graphically by observing a graph to determine what the limit answer is. So I wanted to do 2 of these problems with you and let you finish the others on your own. So we're going to complete the tables to determine if the limit exists at the indicated x values. If the limit does not exist, we're going to explain why. Alrighty, so we're going to do problem 1 and problem 5, the first and the last problem. All right, so we're dealing with the function f of x equals x minus 2 divided by x squared minus x minus 2. So this is our function that we're dealing with. We have an equation for this function. We don't have a graph of it. If we did have a graph, we would just look at the graph to determine these 3 answers right here. So we're going to find what's the limit as x approaches 2 from the left of this function, f of x. I could have replaced this whole rational expression right here with f of x. Then we're going to find what's the limit as x approaches 2 from the right of f of x. And then based on what we find here, we'll be able to answer the limit as x approaches 2 of f of x. All right, so we're asked to fill in these table of values right here. And it's good to kind of pay attention to what's going on in this table. This top row is for x values. And just kind of observe the pattern of this top row. When x is 1.9, what's the y value? And then when x is 1.99, what's the y value on f? Then as x gets closer to 2, 1.999, what's the y value at that point? Do we see a trend of these numbers as we head this way as x approaches 2 from the left? If we don't feel like we have enough information, then we could certainly add another column in here and we could put in 1.9999 and we could keep doing that to see what the trend of those numbers are as x approaches 2 from the left. All right, and now notice what these x values are. We're actually going to come from, let me do this, x is going to approach 2 from the right. So numbers to the right of 2, well, 2.1. And then 2.01 gets closer to 2. And if we continue, notice that the number 2.001 is even closer to x equals 2. Now we're going to observe these numbers, these y values, in this direction. Okay, if we don't feel like we have enough information based on the trend of these numbers and what the behavior looks like it's doing, then we could add another column of 2.0001 and so forth and so on. So let's fill in these table of values. So we're going to go to our graphing calculator. So let's go ahead and enter this function into y equals. Sorry about that. Let's see what's happening here. There we go. For those of you guys that are going to be returning face-to-face, I'll issue calculators if you guys need one, if you don't want to work with the calculator that you've downloaded onto your device. And even if you're an online student, that's fine. If you want to make an appointment to come up to the school, I can certainly get you a calculator as well if you need one. All right, so we've entered our function. I'm going to go ahead and just make sure that I'm in the Zoom 6 window. So I would just look at my window setting. I'm not. I'm going to hit Zoom and I'm going to hit 6. I think the standard window from -10 to 10, is a good window to start with on this function. All right, so I see the graph here. It appears that there's a vertical asymptote maybe at x equals -2, maybe. It's kind of hard to tell. I could readjust the window and get a better picture if I wanted to. But it appears that I do have a vertical asymptote as suggested by the graph at x equals -2. So what I want to do is I'm interested in, before I fill this table in, I'm interested in what's the limit as x approaches 2 from the left, 2 from the right, and then what is the limit as x approaches 2. So what I'm going to do first, this is kind of how I get started. I go, okay, well, let me hit the trace key. It's up here. And then I'm going to hit 2, and I'm going to hit enter. And notice that down here you have x equals 2, but y equals nothing. That tells you that we have a discontinuity when x equals 2. So I'm going to kind of imagine where x equals 2 is. It's probably about right here. It doesn't appear from my graph that there's a hole there or a point discontinuity. It doesn't appear that, but there must be something interesting going on there, because when x is 2, there is no y. There's no y value when x equals 2. The graphing calculator struggles in graphing open circles or point discontinuities, I guess. So you can't believe everything you see. So there is a point discontinuity at x equals 2. If you wanted to, you could go to the window, and I'm going to make the window smaller. Maybe I only want to view the window from x min -4 to x max 4, and maybe the same thing along the y-axis as well. Let me see if I can get a better view. Okay, well, here's x equals 2. I can see it. I'm going to again hit trace. I'm going to hit 2, and I'm going to hit enter. It tells me there's no point on the graph where x is equal to 2. There's no y when x equals 2. There must be a point discontinuity there. And in a later lesson, we're going to see mathematically what determines that we have a point discontinuity or a hole. All right, so the limit as x approaches 2. Now, it certainly seems that since we have a point discontinuity, it seems like the y values are coming into that point discontinuity at about the same location, maybe somewhere about less than 1, about that y value. If you extend where you think the point discontinuity is over to the y-axis. So, I don't know, maybe a half, maybe a quarter, something like that. I think the limit exists, and I think it's going to be some numerical value, maybe around a quarter. I don't know. I'm just trying to kind of predict what I think my answer should be. I think the left limit as x approaches 2 and the right limit as x approaches 2, I think those are going to be the same values, which means that the limit does exist, even though the function's not defined at x equals 2. All right, so to fill in this table, what they want me to do, and there's a couple ways you can do it. You can go to the table feature if you want to, but for me, I'm just going to say, okay, I'm in the trace mode, so if my x is 1.9, I'm going to just go ahead and type in 1.9. Now look, the point shows up. So at x equals 1.9, my y value, and let's go to 5 decimals in AP, so 5 decimals, even in dual credit, we're going to 5. 0.34482 or 83. You can round or truncate to 5 decimal places. That 7 would otherwise suggest you round up to 3, but we can actually just truncate and just use the 5 decimals. All right. Now, let's see what happens when I make that point get closer to an x value of 2 by doing 1.99. Okay, well, 5 decimals, 0.33444, or you could round that last digit up to 5. I'm thinking it's getting closer to a third. Let's get even closer to x equals 2 by plugging in 1.999. Okay. So 0.33344. Now, even though my table doesn't have the next number that's suggested, the next x value that's suggested by the pattern we're using, I'm going to go ahead and just type in 1.99949. I mean, what harm is it going to do? Notice how we have another 3 settling in here in this y value. We can get closer to 2 by doing 1.99 with 5 nines. Now look, we have another 3 settling in. I think if I continued this pattern, that my y values are really approaching a third. So remember, it's the intended height. Okay, so I'm thinking, okay, well, I think if I come from the other side of x equals 2, from the right, I think I should also see a trend that I'm approaching a third. So let's fill in the table of values here. I'm going to start with 2.1. So 2.1 puts me on the other side of x equals 2, and I can see that's pretty far away from 2. You might not think so, but it really is. 0.322, and I'm going to do 5.8. Okay, now remember, we're coming back this way now because x is equal to 2.0. That's even closer. Notice I have another 3 settling in. 0.33, a second 3, 222. Well, we can get closer to x equals 2 from the right of 2, 2.001. All right, so I've got 3 3s and then 2 2s. Well, nothing's stopping me from investigating. Let me just do another x value closer to 2. Yeah, it looks to me like it's going to a third. All right, so we have just now finished filling in our table of values by using the trace feature. It's as we predicted. I think I predicted a fourth or something like that. I knew it was less than a half when I looked at the graph. Okay, so now we come over here, and based on what we see in this table of values, because eventually you're just going to be presented with a completed table, and based upon the behavior in the table, you're going to have to answer these blanks here. So we're approaching 2 from either side of 2. I think that the numbers that are to the y values that are to the left of 2 suggest that I'm approaching a third. I think as I approach 2 from the right and I come back this way, I'm coming into the table since 2 is there, I also think that's a third. So together, they're the same, left and right hand limit, so I'm going to have a third. Okay, I'm going to go to example 5. All right, let's go ahead and produce a graph of this to see what's happening, and we want to investigate behavior on this graph as x approaches -3 from the left, x approaches -3 from the right, and x approaches -3. So we have to investigate left-hand behavior, see what that answer is, right-hand behavior, compare these two, and then report what we think the limit answer is. Okay, so we've got a function. It's trigonometric, cosecant pi x divided by 6. How do I enter this into the calculator? Well, we don't have cosecant. So one thing I'm going to do is I'm actually going to take that 1/6 out front here and multiply by cosecant pi x. Remember, we don't have cosecant, so cosecant can be rewritten as sine. So I've got 1/6 times, and then I'm going to change cosecant to 1 over sine pi x. This is what I'm going to enter into the calculator and investigate. Okay, I'll come back to you in just a second. I have a distraction.